Alright, so in this video I'm going to do 2 or 3 problems where I'm going to find the rate of change. The first one's going to be the rate of change of a linear function, and the second two are going to be rates of change when it's a nonlinear function. So I'm looking at number 4 here, and we have find the rate of change for the data graphed on the line, and the data is for the height of a balloon. And it's important to note that the height is in 1,000 feet. So when this one says 1, that means 1,000 feet. This 2 means 2,000 feet, right? And the x-axis, that should be self-explanatory. It's just goes by seconds. All right. So when you're finding the rate of change for a linear function, right? Linear meaning a straight line. All you're doing is you're finding the slope from one place to another place, right? And it says, and that place on a linear function, that can be any two places as long as they're lattice points. And the reason being is because the slope on a linear function is the same all over the place. So the rate of change over here on a linear function is the same as the rate of change over here on a linear function. Right? So I can start at 0, and let me just find the next lattice point, and the next lattice point would be here, right? And all you're going to do is you're going to draw a slope triangle from one point to the other point, right? It's going to go over in the x direction a certain amount, and it's going to go up in the y direction a certain amount. The amount that it goes over is going to be your run in the rise over run equation, and so it goes over by 30 seconds, so it's going to run 30 seconds, right? You can write 30s, 30 seconds. And then it goes up by 1 box, but here's what's important. 2 boxes is 1,000 feet, therefore 1 box is only 500 feet. Okay. And then you can divide these two things. This is 100 feet. All right. And if I divide these two things, I just do 500 divided by 30. Oops. Do 500 divided by 30, and I get 16.67 feet per second. In terms of rate of change, it's totally okay to have decimals because we always want it. We always want a 1 on the bottom, so that way it's a unit rate. So 16.67 feet per 1 second. That's what happens when you divide them. All right. So let's move on to the next one that I want to do. And the next one I want to do is the first average rate of change problem with a nonlinear function. What's important about these is it says calculate the average rate of change on the intervals, right? This word is important. These brackets, they are not the same as an xy coordinate that has the curved brackets. Whenever they have square brackets, these are both x values. This is x1 and this is x2. So just keep that in mind. You'll get used to that before the benchmark, but just keep that in mind. So x1 is 1 and x2 is 5, right? So here's what you have to do. You have to go to x equals 1 and then go to the function. So the first point they're talking about is right down here. Right? I go to the x value of 1 and then go to wherever the function is. Next, I'm going to go over the x value of 5 and go to wherever the function is. They want you to find the rate of change between these 2 points. And the way you do that is you draw a straight line, regardless of what the function looks like, draw a straight line between those 2 points. And once you do that, it's exactly the same as finding the rate of change of a linear function. You're just going to use your linear line that you just drew, okay? So if you can find the slope of this line that you drew between 2 points, you will have found the average rate of change. So let's do that. We can still use rise over run. It's just as simple right now. And the amount that they quote-unquote rise, you're going from -4 to -12. That's a change of, that's a rise of -8 or a drop of -8. And then the amount that so this is the rise, all right, as they say. And then the run is here, and you're going from 1 to 5, so that's a space of 4, okay? There's no units here, so don't worry about those. -8 divided by 4, the average rate of change between those 2 points is -2. So let's do number 5 now. Number 5, x1 and x2, excuse me, because they're square brackets, they're not going to be a coordinate point, they're going to be an interval of x values. So we're going to do the same thing between 5 and 7. I'm going to go to 5. I'm going to go down to the function. So right where my other one ended, that's where I'm going to start. And then I'm going to go to x2, which is 7, and go to the function. If I create a linear line between these two, geez, excuse me, I'm going to find the slope of this new triangle now. It looks like it goes over by 2. So if I do rise over run, my run is 2. And my rise actually goes up from negative 12 to negative 4. So it goes up by 8. 8 divided by 2, your average rate of change from 5 to 7 is 4. So depending on a nonlinear function, depending on which 2 points you're going between, the average rate of change may be different. It just depends on how steep this line is between the 2 points that you've drawn. Okay, so that's it. Feel free to watch this video as many times as you need until you get it.